Yolanda. Fantastic. All right. Moving along, our next presentation is on the future of LED and outdoor lighting control, or OLC, with Sylvania Lighting Australasia. SLA is one of Australia's leading lighting companies and the dominant supplier of roadway lighting across Australia, and you'll find many of Australia's major sporting facilities and commercial projects incorporating products and lighting expertise that has come from Sylvania Lighting Australasia, SLA. Our speaker is the Executive General Manager for SLA, and Mark West. Mark moved from the electronics industry to the lighting industry following the early incorporation of electronics into lighting, starting with SLA in the early 1990s. His background has been technical and compliance-based for over 25 years in both the UK and Australia, with sales, marketing and product design experience within the Australian lighting market for over 20 years. In his career, he's been responsible for product design that number over 20 families, many that have won lighting awards, and with an installed base of over 1 million units throughout Australia and New Zealand. So let's hear about the future of LED and outdoor lighting control. Could you put your hands together to welcome Mark West? Mark.
Thank you. That was a big bio, wasn't it? I hope I can stand up to that. So thank you for this opportunity. Thank you for the sponsors and all the attendees, and for Expo Trade to put this on. I'd like to talk a little bit about who we are, and indeed where we think the future of LED lighting is. There's been quite a few comments made about LED is a very exciting technology. We think it's an excellent technology, but most light sources have some novelty, have some utility and some benefit. So it should be always considered within the suite of technologies that are available. But specifically today, I'd like to talk about LED. It's very topical. I'd like to talk about a little about the balance of LED. There's a lot of discussion of analog to digital. That metaphor comes out quite a lot. It doesn't really portray the depth of balances and compromises and conditions that need to be considered when selecting a technology choice. So I'd like to talk a little bit about that balance. If it gets too technical, please just shout at me or throw something at me. I'll try and move on. I'd also like to talk about trying to balance lighting for the planet versus the person, which is a very topical discussion. I think other speakers will touch on that too. I'd like to also go into a little bit about outdoor lighting control. Indoor lighting control is a fairly mature industry. White light indoor lighting is typically run by control signals through DALI, and for coloured light is typically run through DMX control. Outdoor lighting is a bit more technical. Typically there aren't control wires going to the product, so I'd like to touch a little bit on that and where I think that's going, and some of the facilities that we have at our disposal to test those technologies. A little bit about Sylvania, if I may. I'll try and keep it short. We're 300 plus people. We have a major facility on the Central Coast, about an hour north of Sydney. It's 9,000 square metres, consists of two buildings. One on your left is the assembly facility and test, the laboratory and the administration, and the one on your right is the distribution centre. We've been in Australia for over 40 years. The brand of Sylvania originates from North America and is over 100 years old. You might recognise some of those brands, Sylvania being the prominent brand. Interior architectural products such as Concord, Gadini, which is an Italian make, Citeco, which is formerly Siemens Lighting, which is a German manufacturer. Luminance is a Dutch company. Victor Lighting is for explosion-proof lighting. We use a lot of that in the oil and gas area. And there are many more. Representing those brands, we have a suite of product portfolio that is second to none. That allows us to select everything that we can, but that's not always enough. We also feel that Australia's a big country, it has a lot of temperature ranges and cyclonic wind conditions. Sometimes you have to develop luminaires specifically for the Australian conditions, and we do so. Everything through from concept to proving the solution, tooling, assembling the product, testing the product both in compliance and development testing, and then obviously selling the products hopefully to customers like yourselves. We do that because we can maintain control. It's a very 50s business model. You look at a lot of lighting companies, a lot of electrical companies, they outsource a lot of that. We try to keep that in-house so we can control it and maintain the product integrity throughout. We have a test laboratory, photometrics to measure the light output, temperatures, all of these conditions which significantly impact on the performance, the quality and the life of the product. It's very good to receive a test report from an overseas, even an accredited manufacturer, even an accredited laboratory, but to physically test the product and ensure it's viable. We take that very seriously, and it's only one of the few laboratories in Australia, and it's accredited to NASA as well. We also have a test road. This is the only one in the Southern Hemisphere that I know of. So we have a road between our two facilities, and we have 7 poles and 6 lights per pole that can be switched individually. We use that for testing the outdoor lighting controls, which is very new, needs to be verified before it can be installed. We also use it to simulate technologies, and most importantly, I think, although thoroughly undervalued, is to physically look at what lighting will look like before it goes in. It's very easy to do a light design on a piece of paper, pick a spacing, replace a light on every second pole, but to actually get some concept or some perspective of what that will look like in various conditions, I think is important. So we have that test road. I'll talk a little bit more about that later. So that's about us. I'd like to talk a little bit about LED lighting, as I said, and I'll move straight on. I'm sure everyone's seen curves, a chart similar to this. I won't get into the detail, but fundamentally commercially available LEDs now are very efficient. If they're managed properly, they're very efficient. There's a little bit more to go. It's a dotted line. We know there are some more efficiencies to come. I'll talk a little bit more about that as well. The other technologies that are currently incumbent are there. It is a little misleading, that chart, I think. It's boiled everything down to a singular factor, which is the lumens per watt. So the column, the vertical column talks about how much light you get for the power that you put in, and then you have a time base as the horizontal. It doesn't really describe all of the aspects that I was speaking about earlier about lighting. So I'd like to touch on a few of those. If I had 2 hours, I could touch on a lot of them, but I probably would bore you all. First thing you need to worry about with LEDs, first, foremost and utmost, is temperature. If you don't run LEDs at the right temperature, you will significantly impact the life. A 10% increase in temperature can halve the life. A further 10% increase in temperature will further halve the life. If that is not managed with the greatest of prudency and care, you will significantly reduce the life. And you may not see it for 1, 2 or 3 years. But if it fails, it could fail catastrophically, an avalanche condition. So it is important to manage lifetime. There's a few curves there. This is a Cree LED. The one on the left is being driven at 350 milliamps, that's 0.35 of an amp. And you'll see the curves there. Again, we have life as the vertical this time and temperature as the horizontal. As you move along the curve, so you will reduce the life significantly. If you then, the one on your left is 350 milliamps, the one on your right is if you run it at twice the current. LEDs are very open to being run at various currents. If you increase that current, you reduce the life again. I'll touch a little bit more on that, but before we talk about any of the balances about LED and lumens per watt, and efficiency and colour and everything, if we can't manage this temperature issue straight away, it's irrelevant. This is the first and foremost. If you can get the temperature right, and there are mechanisms, standards and guidance to assist in that, then you move to the specifying an LED. Now all lamp sources depreciate over life. This was spoken a little earlier. I think it was in the video for the induction lamp. It is important that you provide the light, the minimum lighting level that it that your application needs at the time you change the light, not at the time you put the light in. So you'll hear terms of L80 and L70, that is 80% of the light is still available at that temperature, at the junction temperature. So we're getting a little bit multi-dimensional here, but this term of L80, L70, L50 is very important for understanding the life of the product, which is very variable. To speak a little bit about the power, temperature, and a little bit about the drive current. This is a pentagram, and I've put multiple facets on this. Lumen output, the actual amount, the absolute amount of light, is the top one. Moving to your right, you have efficacy, which is how much you get for your power. You move around to the colour, which is very important. The colour I've left as one dimension there, but it could be colour temperature, CRI, or colour tolerance, all of which are very important with LED. Additional functionality, I'll talk a little bit more about that in control later. And then the cost. The dollars per lumen, or dollars per 1,000 lumen, which is coming down. I'll talk a little bit about that as well. So the red profile is where LEDs are now. They are still relatively expensive. There's dollars per kilowatt, dollars for amount of light. The lumen output is very impressive, but there's opportunities for that to increase. Efficacy increase. Colour is fairly stable. There's a little bit more to be done in phosphorus, but not a lot. And then functionality, which again we'll talk about a bit more later. So the balance. I'll skip that. So if we move to lumen output, if we increase the lumen output, we can do that by many factors, by better quality LED, drive a little higher with current, distribute the light more efficiently. But typically, if you drive the current higher, you will suffer a reduction in life and efficiency, and the cost will go down. It's a counterintuitive position that more lumens means lower cost, but the sacrifice is the life. Whereas if your efficacy is your imperative, you will suffer the lumen output. Absolute output will drop. You can get better efficacy, better lumens per watt. The cost will go up. You can do this by many mechanisms. You can typically drop the drive current, but the most easiest way to improve the efficiency is increase the number of LEDs. So instead of having 10 LEDs running at 700 milliamps, have 20 LEDs running at 350 milliamps. You'll increase the efficiency, but unfortunately the cost will go with it as well. Colour. Right, this is tridimensional, three-dimensional. Colour temperature is very important. The tolerance of the colour, I'll talk a little bit about tolerance. LEDs have a tolerance, a binning. One colour can look different to another. So if you look in the tubes, you have pink fluorescence here and yellow fluorescence. It's the same tube, they're running at different colour temperatures. Actually, those pink ones shouldn't be pink, they need to be changed. Ian? So fundamentally, the colour temperature is very important for the application specific. Colour rendering index is the ability for the object to be presented in the manner of which it would look like under sunlight, in a true manner. That's very important as well. And I'll talk a little bit more about those. But typically, especially when it comes to temperature, the warmer an LED is, the less efficient it is. They're getting better all the time with the phosphors and the improvements, but typically the cooler the product, the more efficient it is. The warmer the product, the less efficient it is. I hope I'm not scaring anyone off LEDs, please. That's what happens if you don't get binning correctly. Binning, we talk about colour tolerance, that's all the same LED. That's the same luminaire coming out of the box being installed by the installer who is dutifully upset because there is a raft of colour variation. It is important to maintain those colour tolerances, and the Australian Standard for Street Lighting, which is our public draft now, has that in that, which is welcoming and pleasing, but it is very important. How that is done is you can have colour bins. The human eye won't pick 50 or 20 or 100, maybe even 100 Kelvin. Temperature's measured in Kelvin, same as physical temperature. But you will get to a point where you can go outside of that and you will see a perceivable difference. That is unacceptable in lighting and needs to be managed. So that's the three main ones that everyone talks about: power, lumen efficiency, colour. I'd also like to talk a little bit about lumens per watt, but before I talk about lumens per watt, it's important to know how much more is in the tank with LED. These things are always very controversial. When I put the slide up, I'm expecting 3 or 4 suppliers to put their hand up and tell me it's wrong, but I'm going to do it anyway. There's 5 or 6 places you can get efficiencies out of an LED. Conventional light sources, you mess with the gases, or you mess with the phosphors, or the pressures, and you had a few choices. You have a lot with LED. The internal quantum efficiency is the light is produced at a molecular level, and you've got to get it out. If it sits there bouncing around at that quantum level, you can't physically get it out, you lose. There's a little bit left in there, actually probably the most of it's left in there. The electrical efficiency, getting more into the control gear there, that they're pretty efficient already. I can't imagine there's huge savings to be done there. The extraction efficiency, once that light at a quantum level is leaving the P&N junction, it's a diode, it's physically got to get it out, and you've got to actually extract it and distribute it. Phosphors, I spoke a little bit about phosphors. The light coming out of LED is blue, and typically blue, other than there are some colour variations, but the most efficient is blue. That's converted to white by using the yellow phosphor. There are different ends of the spectrum. Those phosphors are very efficient, and they become very efficient now. A little bit left in that, and then there's the package efficiency as well. If you combine all of those, if you combine all of those, we probably have around 150 lumens per watt at a chip level. It might hit 200 lumens per watt. That's for colour, that's for white LED, that's for blue LEDs that are converted to white by phosphor. Colour LEDs, where you produce a pure red, a pure green and a pure blue, and you mix them, the efficiencies are much higher. If we go back to the previous slide, oh, I'm going the wrong way, you've just seen the whole presentation. I'm going now. Need a keyboard. You'll see there the LED colour efficiency has a lot further to go. That is very pleasing, but unfortunately, if you have a pure light red, a pure blue, and a pure green, the white you get is very shallow, very unattractive. So the efficiencies that you can get from not actually having phosphors are not very practical in day-to-day use. But it is worthy to know. I won't jump around so much. Right, so the lumen efficiency, we spoke about lumen efficiency, there's a little bit more to go. These LEDs are getting better every day, and the cost is coming down. This chart is something we've done. We took I shouldn't have put the brand up there, but there's an LED up there, and we've been buying this since 2010. It's a 1 watt LED. You can see that originally its output was 90 lumens for 1 watt. It's quite a lot for 2010, and it cost us $2.50 for a watt. So effectively, we've got 36 lumens for a watt. A year later, it's 100 lumens per watt, and the price came down 50 cents. It's a bit like televisions and computers. The efficiency is now up to 127. It's gone up 30% plus, and the cost has fundamentally halved. So the lumens per watt has trebled from 36 lumens for a watt. 36 lumens for $1 to nearly 100 lumens for $1. This is continuing on as well. This is very exciting, because this, and there'll be a slide later to encapsulate this. This fundamentally means that LEDs are becoming more and more useful in a range of applications because of their costs. It's a more detailed slide again, showing fundamentally the same thing of in mid-2009, and certainly in the early days, you're talking $20, $30 for a watt. Only the early adopters use that. As we move down, we get it down to $1 a watt and below that. And then the efficiency improves too. I'd like to summarise quickly, I don't know how I'm doing on time. The LEDs, I'm sure you've all heard this before, it is all true and real. Very long life, very inefficient, very rugged. There's no filament in there, they can't be damaged if you drop them. If you drop a filament lamp on the floor, or even an arc tube, a fluorescent or an arc lamp on the floor, that's it, it's dead. LEDs will shrug that off. They're instant, they're very directional. The most efficient way to distribute light is to have a point source. It's also the most difficult way to distribute light because point source is glary. If you have a point source, you can wrap a reflector around it very tightly and distribute the light exactly where you want to go. LEDs have given us the ability to do that unprecedented. We've never seen it before. We can get such high sophistication in our light distribution, which improves the efficiency as well. No nasty substances. Infinitely dimmable, very stable, but you've got to you've got to be very cautious with the temperature. This is what happened as LEDs get more efficient. They started off as indicators, for want of a better description, or they started off on mobile phones and traffic signals. They've then moved to colour lighting, to wellness, residential areas. You're starting to see them coming up in hospitals, architectural lighting. And now general lighting is certainly feasible for LEDs. They are very efficient, especially if the lumen package is low. If it's under 2,000 or 3,000 lumens, LED is almost unsurpassable. As that package increases, the power you need, you run into some problems that you need to manage. So I spoke about the summary. There's one comment here, and I think my esteemed colleague from Zunzibel will talk a little bit more about lighting the environment, but as opposed to lighting for the planet. LEDs have become synonymous with lighting. People don't talk about changing lighting, they talk about buying LEDs. Yet good lighting design is still the starting point. LEDs are an input to lighting design, not LEDs a replacement for good lighting design. It's very important that you use a good lighting designer to understand what you need and then select the technology as opposed to arbitrarily rolling out LEDs just because everyone else is. We're finding quite a bit from our perspective where LEDs have been put in and poor lighting practices are creeping into this industry and that's unsatisfactory. So I spoke on that pentagram, I spoke everything about the colour, the output, the wattage, the lumens of the efficiency. I hope you'll took note, there'll be questions later. But I didn't talk about control. Now, as I said earlier at the intro, outdoor lighting control is new. That's new in terms of lighting as a time frame. Indoor lighting control, I won't even bother talking to you about. It's done. It's very easily managed, very cheap, very efficient. Outdoor lighting control is still in its infancy. Now, as I mentioned, some of the resources that we have at our disposal to verify this technology. The first one is the test road. So if you don't mind, I'll jump back to Gosford. This is our test road. So we have multiple light sources on poles. And I'd like to show you just quickly, how am I doing for time, by the way? 2, right. So I'll quickly go through the category P. This is various lighting technologies at category P. 80 watt mercury from the left to 25 watt LED to the right. P4, we bring sodiums in. You can come back to these at any time. P2 on your left is 100%, P2 on your right dimmed. You can see there that the actual vista, the actual appearance of lighting, even though the lighting output is much lower, is still very appealing because there's multiple light sources, good uniformity. Good uniformity provides an opportunity to dim. Rear lighting control, I think a gentleman from the council spoke about rear lighting control. It's very important to maintain that. In some of those images you can see the car, and some of them you can't. That's just managing the rear control. Category V, a high level of output. That test road is, I think, it's for the lighting community. We've even had competitors come up and test their lights there as well. So look, there's standing invitation for those, any of those that want to travel up to sunny Gosford. Got electricity and water now, it's all good. So you're more than welcome to come up, but if it's too far to go, we can do a presentation in your office. We have webcams to simulate the road. So it has to be dark though. Statement, I guess. Right. I won't get into the technology too much because I'm running out of time, and some of these slides are taken from other lighting control companies, but fundamentally with outdoor lighting control you control the light, the node, the device, the luminaire. That information is typically collected by a segment controller, a controller. Think of a wireless hub in your house. The wireless connection, the modem, is your internet, and then it provides the information to your house. Typically you need hubs. At the moment you need hubs. They could be a wired system or a wireless system. The wired system, which is this particular one, injects a signal onto the mains voltage, travels along the mains voltage, the two wires that provide the electricity, and that signal is then interrupted or intercepted by the light source to then turn on, turn off, and feedback information. Various controllers there. The next steps, you have your hub and then your devices. So you're connected to your devices, the hub is on the internet. You have to pair the devices or load the devices. So there's a lot of techniques where you can actually scan labels on the products. You can use GIS information systems, GPS to isolate and allocate your product so you know where it is. All these steps are the same for wireless and wired. The language might be changed slightly. Wireless, you'll hear terms of mesh. This is a supplier that's got a very unique product, which is doing very well in Victoria, more so the network than this particular photocell device, but certainly each device becomes a receiver and a transmitter. Typically the comment used to be there's no substitute for copper. No. Whenever you used to do control signals, put a piece of copper to it because there's no substitute. Wireless systems now are very, very reliable. If they see a signal that is not, if they see a channel that's being interrupted by noise, they'll move to another channel. If one device falls over, the others will step in and take over. Very, very exciting. We're agnostic on controls. It's our job to sell lighting, and we have all of these control systems in Gosford that we are there at verifying. Then you manage it through a web user interface, iPhone. I think somebody said earlier about controlling a phone, a street light from an iPhone. It's here now. And that's where it fits on the world of IPv6, the internet of everything. One day you won't need a hub, you won't need a wireless device. You talk straight to that particular street light. That street light will talk to the waste paper bin and talk to the smart controller, and heaven knows what opportunities will come out of that. But that's typically where it is. We're actually seeing coming in from the top and from the bottom. So we're seeing a lot of inquiries for controls for lighting. That's one network. The gentlemen's are here. I haven't mentioned any brands, but that's for smart meters. So it's here, gentlemen. Wireless control is here, and wired control. Costs will come down. It'll certainly be the next wave of technology for lighting. I think I've overrun. I do apologise. Thank you.
Don't go. I do have a little gift. I suggest, I'm sure there are questions about the presentation and a bit of an information dump, but yes, the guys are outside, happy to answer your questions, so go and buttonhole them over lunch. On behalf of everybody here, thank you. Excellent. All right. And fantastic presentation to take us up to